All right, here we go. Welcome to lesson 5.1, starting a new chapter here. Chapter 5, you look back at the big picture, it's rational exponents and radical functions. So we'll actually hit a lot of that stuff. We'll hit for sure rational exponents today, talk about what are they, how they, some properties of them, a little bit more properties of exponents in the next lesson. And then second half of the chapter, we'll build towards some of the operations among functions and doing a little bit of graphing on radical functions at the end. So let's just jump in. Let's get it going. Lesson 5.1 specifically, nth roots and rational exponents. So we'll come back. We'll check all this stuff off as we get going here. Try to give us as much room as possible. Here we go. First thing, so nth root. When we say nth root, a little bit of just kind of background here is mainly what this is. I don't know. We don't necessarily have to add all this to our notes. I think a lot of this is what we do know this. 5 to the second power 25, obviously something we should all know. But that means what we would say is that 5 is a square root of 25. And again, I think something we all know, probably don't necessarily have to add it to our notes. The square root of 25 written that way with our symbol for square root. Similarly, 3 to the third power, 3 cubed, you could even say, is 27, which means that 3 is the cube root of 27. One that I'm sure we've seen, but beyond square root, any other root that we're gonna perform, we want to indicate that that's not a square root. We need to differentiate here between square root versus cube root, fourth root, fifth root. This is what we call the index in here to let us know like what root we're actually taking. But 3 times 3 times 3, 27, 5 times 5, 25. Still, I don't know how much of this we need to add to our notes. Just a little bit of background on the kind of where we're going with this stuff. Kind of what's behind us here when we take, it's a property of exponents. If I take a power to a power, we multiply the exponents. So 1/2 times 2 is 1, a to the first power. These two powers essentially undo each other, right? 1/2 and squared, I get a to the first power. They kind of cancel each other out. Same thing with the 1/3 power to the third power. And when you talk about operations that cancel each other out, we're talking about inverses. We'll get into some of that stuff later. You can see it down here. This is the big takeaway. Because a to the 1/2 is a number whose square is a, you can write that as right here. The square root of a can be written as a to the 1/2. So this is definitely right here. This first part highlighted is something we should add into our notes. You can put it under a heading of just, I think it's okay to call it nth roots would be like the name of the section, nth roots. But in general, the nth root of a number is equal to 1 over that root, a to the 1 over that power, or 1 over that index. Does that make sense? That this right here is kind of the generic note that we can turn any root expression into a rational exponent expression, their equivalent. Okay. A couple other just properties that go right in this section. So hopefully you got a section, nth roots. We can go right in that. Just rational exponents can be part of this section. To extend it a little bit further, a to the m over n power, just kind of, it's really just about where do these numbers go when I want to go from what we would call a rational exponent, right, a fractional exponent, maybe back to something with a root symbol. I need to know basically that the denominator of that fraction ends up being the index of the radical, and then the numerator of that fraction ends up acting as like to the power of. Okay, we'll do some of this. We'll practice with it. This is a pretty big skill for us, just being able to go from this form to this form, or vice versa, from this form back to this form. So that's part of the stuff we'll do. We'll practice here. One other property that comes up, property of an exponent, that hopefully you would have seen in an Algebra 1 class, but we'll review it here. We'll even review it in the next lesson. How do we deal with negative exponents? Really, what I say is to fix a negative exponent, you change its location. So we can see here a to the negative m over n power. I say, hey, you know what? We can make that positive m over n anytime we want. I just got to change its location. Right now, this whole expression a to the negative m minus n is taking place like in the numerator of a fraction. So if I want to fix that negative, I say, no problem. Just bring it down to the basement. So now I've got 1 over a to the m over n power. And we perform the exact same operation. Here we got a limit. We don't want a to be 0, the denominator of a fraction to be 0. So there's a little bit of that there. But really the big thing here would be to fix a negative exponent, change its location. Similarly, if we started with something like this, and that you'll come to see that that's something we definitely want to do, is what I would say fix a negative exponent. We would say, all right, I can fix that. Right now it's in the denominator. If I want to fix it, I need to change its location, bring it to the numerator. That's how we would fix that. So those will come up here as we look at a couple examples. Really, like I said, just at this first part is just kind of getting comfortable changing forms. So here we go. Pause, get it set up. Rewrite the expression using rational exponent notation. So basically turn this, going from a radical, the cube root of 6 to the second power, what we would say there, turn that into something that has an exponent. I guess has a rational exponent. I guess there is an exponent, 2. So it's really just the kind of the nuts and bolts here of what goes where. The base stays the same. We never mess with the base. The base is 6. That's the base of my power. And then it's really a matter of is it 2/3 or is it 3/2? So we said this index here is always going to be our denominator, and then the power here is always going to be our numerator. So we should have ended up with 6 to the 2/3 power. Same exact process here with part B. The one thing we do have to watch, a radical symbol, there's an implied parentheses underneath it. It's a grouping symbol. So even though we don't see this group here, it's there, it exists. So now the reason I bring it up is when we come out and we get out from underneath this radical, we need to still make sure that our base remains a -2. So now I actually do have to insert the parentheses and show that, yes, that's a -2 base. But just like before, where did this 4 and this 9 go? This would be -2 to the 4/9 power. Okay, so that's going one way. You've got some expressions with root symbols. We're going to take them to rational exponents. Guess what's next? Go the other way. Okay, go from 9 to the 5/3 power, -28 to the 7/5 power, and let's write those using radical notation or with insert a root symbol. So just like before, I'm going to make sure that my 9, okay, that's like my base. That's what we're going to be taking the root of. It's just a matter of getting these numbers where they go. So we said the index should be 3, and my power that I'm going to be raising this to is to the 5th power. Okay. B is a good look at just the one we just did above. We can lose the parentheses now and just say we've got a -28 underneath our radical. And our index should be 5, and we're going to raise this whole thing to the 7th power. Okay. That's a pretty big skill for us because obviously certain things, if these get flip-flopped, that's a common mistake, but something we got to make sure we have a good grasp of, knowing what goes where, how to change forms. Okay. Roll it right into example 2. So now we'll see a no calculator section as well in this chapter, like we saw in the previous one, or in other chapters. Evaluate the expression without the use of a calculator. Yikes, that's scary. 8 to the -4/3 power. Ugh. How do we do this? Okay. This one's got a couple things we need to address. That negative exponent, like we had talked about. I think the first thing we should be doing with part A is let's fix that. And again, when I say fix, I mean change its location. So right now, this whole thing is taking place in the numerator. I'm going to move it to the denominator, 8 to the 4/3 power. So that's all that first part is just change your location. Okay, great. Still, that right there is, I don't know what that means. 8 to the 4/3 power. Are you crazy without a calculator? If that's what you're thinking, change forms. Or you're like, I don't know what to do from here. A good strategy is to just, let's look at this differently. Let's change this, just what we were doing a second ago. Get everything where they're supposed to go. Now I look at that and I say, I still really don't. What does this mean? Now it becomes like an order of operation problem. Hold off on this power of 4 for right now. What is the cube root of 8? Or in other words, I need a number that I multiply by itself 3 times and I get 8. So there's not a whole, there's one option, right? 2 times 2 times 2. 3 times 2 times 2 times 2. I meant 3 times as in you're multiplying by itself 3 times. 2 times 2 times 2 is 8. So right now, I can simplify this and say this is no different than 1 over 2 to the 4th power. Okay, so we've evaluated the cube root of 8, which was 2. And now I'm raising 2 to the 4th power. It's the same base. I need to multiply it by itself 4 times. So 2 times 2 times 2 times 2, 16. So when it's all said and done, I kind of took a roundabout way to get here. This simplifies to 1/16, 1 over 16. So again, that's all getting done without a calculator. I would expect everyone can do 2 times 2 times 2 times 2, whether it's paper, pencil, or in your head, to get 16. Okay. Now, obviously, we can't do this with all numbers. These are strategic numbers. This 81, this 8, these powers, or this power here, this 3/4 power, this negative 4/3 power. I couldn't ask you what is the 7 to the negative 4/3 power. That we're not doing that one without a calculator. Okay. So these are strategic numbers. Similar idea here. Okay. Let's change forms. Let's just get it looking at it in a different way. Because admittedly, I see 81 to the 3/4. I don't really have a great grasp of what that means. But when I see it like this, I can say, all right, well, now I'm looking for a number that multiplies by itself 4 times and gets 81. So I could go down my list. We just did 2 times 2 times 2 times 2 4 times. That ended up with 16. So it's got to be bigger than 2. You go to your next one. 3 times 3 times 3 times 3. All right, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Again, you might have to paper and pencil that, but that's where we end up. The 4th root of 81 is 3. And now I need to take that to the 3rd power, which we just said it. 3 times 3 times 3 is 27. So that'll take some practice. You'll start to see, though, some of these same numbers. You'll probably get to know really well 2 to different powers. 2 to the 3rd power is 8. 2 to the 4th power is 16. 2 to the 5th power is 32. You'll start to recognize some of these numbers, especially the smaller ones. The smaller bases, 3 times 3 is 9. 3 to the 3rd power is 27. 3 to the 4th is 81. Beyond that, yeah, they get big, and you probably have to paper and pencil it a little bit, but we can do those. Okay, so we'll practice that. Keep more examples. Here we go. Other types of things. This is just a straight up get to know your calculator. Make sure you know how your calculator enters or how you enter roots beyond a square root. We've done a lot of square root stuff this year, but we want to make sure that we can do a 6th root. That we can take something to the 4/7 power. So make sure you've got your calculator. I'll let you know what these are. I'm going to crunch them myself. I don't have them written down. The 6th root. So you're looking for buttons that look like this. The calculator that I'm using has a button that allows me to change the index. It looks just like that. It's right over. It's near the square root button. It's a second function on this calculator. So for this one, the way I have to type it in, I have to type the 6 first. That's how I change the index. I'm going to push that button, and then I'm going to push my 112. Okay, so 6, that's how I'm doing the 6th root of 112. And again, I can't just divide by 6. Basically, what this works out to is the number that my calculator gives back to me. It's a decimal number. It's a continuous decimal. I'm talking 2. If I round to the nearest hundredth, 2 places there, it's actually going to be about 2.20. So that means that if I multiply this by itself 6 times 2.2 times 2.2 times 2.2, we're going to get close to the 112. It's not going to be exact just because we've rounded the answer now. But yeah, that's what's going on there. So make sure you can find that. If you can't find it, when you get to class, make sure you let me know and I can help you find it. With B, now I'm going to double check. I don't remember if this is one that some calculators can handle it as is. I would definitely use parentheses around. You might be able to type it just as is. Okay, type that into my calculator. Parenthesis negative 2427. Close my parenthesis. I'm going to take it to the. This is how I would type in to the. So to the. I'm going to use another set of parentheses and just type in 4/7 as like a division, as like a fraction to the 4/7 power. My calculator spits back a domain error. Okay, so there's stuff going on there. What I think is happening with the calculator is it somehow wants to take an even root of a negative number, and it's thinking that it can't do that. Although we actually are 7th rooting at some point here, so potentially run into a spot like this. What do I do? Right? There is a real number value of this. How do I evaluate it? This is another one that I would change forms. Okay, so if I change forms here and write this as the 7th root of negative 2427 to the 4th power, so it's just another look at where being able to change forms is going to allow us to evaluate something that we maybe wouldn't be able to just type straight into our calculator. So now I'm going to type it kind of similar to this one. I'm going to push the 7 first, change my index to 7, negative 2427. I can push equals after that first part. Where'd my mouse go? I can type in the 7th root of negative 2427, push equals. I get negative 3.04495. Now I just need to take that number to the 4th power. I end up with, here's the big reveal, find out if you did it right. 85, so 85.97 if I'm rounding out to 2 places. That one's a little bit harder to kind of think, like, what does that actually mean? It's basically, if I take the 7th root of this number, I got that was that 3, whatever it was. And then I take that to the 4th power, that's where we end up. So calculator work, we can do it. I do have one here. Why not? It's already set up. We may as well just practice it. You pause it, give it a shot. This would definitely be part of a no cal. I don't know why it doesn't say that in the directions. Evaluate without the use of a calculator. Okay, pause it. I'm going to run through the solution. So it's another one that a couple different negatives going on. It's a good look for us too, and I like having it on here. This negative is negative. I can't fix that. Like the base is negative. But the first thing I might look to do is right now, right, this whole thing is taking place in the numerator. If I fix this fraction, I'm going to come downstairs and make it negative 125 to the positive 2/3 power. Okay, the negative base has got to stay negative. I don't have any ability to quote unquote fix that. Okay, so that's been addressed. Next part would be to change your forms. Okay, so I'm going to stay down here. I'm going to get my negative 125. We're going to take the cube root of that and eventually take this to the 2nd power. All right. Now, again, we talked about going through some of these. I need a number that multiplies by itself 3 times, and I get a negative 125. So the number is going to have to be negative. You could roll through them, but this might be another one that you'll eventually probably recognize. 5 times 5 times 5. So 5 times 5 is 25, and then 25 times 5 is 125. We said it's going to have to be a negative 5 because that's the only way to get a negative 125. And then we're going to finish up with taking that to the 2nd power. So negative 5 times negative 5 ends up being positive 25. So when it's all said and done, this is just an equals negative, the quantity negative 125 to the negative 2/3 power has a value of 1/25th. Well, maybe 0.04, but again, you shouldn't have a calculator. You wouldn't be doing that on a calculator, but that's probably what it would return to if you just typed it in just like this. Okay. All right, really the last section we need here of notes, those are all examples, is going to be to help us solve some equations. So if you can look, if you're looking ahead here, these are the last couple examples we'll do. Is involves equations solving. So the note we got to take here is basically how many different solutions should we have. I think this maybe is a little confusing here. Let's clean it up here, okay? So we can leave this as our heading. I'll do it more, try to do it more like we would do in class. Real nth roots of a. So if I'm taking an even root, okay, even roots. Okay, I'm just thinking how I want to do it and make it somewhat manageable. Even roots. So this would be something, n is an even number. That's basically what that means. So again, we're taking a square root, a fourth root, a sixth root of something, and this is all part of solving an equation. How many? It's basically how many solutions should we get? So if we shouldn't, this one we should know because we've done a lot of even root, we've done a lot of square root solves. So if a is positive, greater than 0, how many solutions do we get? 2 real solutions. Okay, so that would be an example of, again, even if we just looked at square roots of stuff, the square root of 25, if this was part of an equation, I really should have it as part of an equation. X squared equals 25, you would square root both sides of that and say x equals positive and negative 5, right? That's going back into our into the files there a little bit, going back a few sections. The second situation would be, or let's just write this out, x equals positive negative 5. If the number we're trying to square, or fourth or sixth root, is equal to 0, we end up with one real solution. So again, we end up in a situation where x squared or x to the fourth or x to the sixth equals 0. I can solve using square roots, but I end up with one solution there. X equals 0. That's it. There's not a positive, negative, 0. And then the third scenario, if a is less than 0, aka negative, we're going to have 0, no real solutions. Now, I know we've done stuff in the past. X squared equals negative 4. Knowing what we know from chapter 3, we could say, hey, the solutions are positive, negative 2i. But if we're just talking real roots, there's going to be no real solutions in that situation. Okay. So it's kind of just knowing when should I have one answer, when should I have two answers, when should I say no, I have no answer, no real solutions. Okay. The one that we haven't spent as much time with would be, how do we phrase it here? Odd roots. Okay. It's the same setup, the nth root of a, except now n is an odd number, right? So we're solving the equation. We're going to cube root to finish it. We're going to fifth root to finish it. This is different. It's a totally different setup. So if I'm talking, if that number underneath the radical is greater than 0, positive, we end up with one real solution. example would be x to the third equals 8. And it takes a little while to practice because we're hopefully so used to like, oh, two solutions. Right here, we would say what? X, if I solve this, if I cube root both sides of the equation, x equals 2. It's not negative 2. And if you think about it for a second, it should make sense. Like, right, 2 times 2 times 2 is 8, but negative 2 times negative 2 times negative 2 is negative 8. So that's why. It's not like I'm making this rule up. It doesn't work out that way. The math doesn't work. This one stays the same. So if a ends up being equal to 0, we still end up with that same one real solution. All right, so it would look something like x to the third power equals 0. You cube root both sides. X equals just a single answer, 0. So that part stays true whether it's an even or an odd root. The one that flips it here then is if a is a negative number, is less than 0, you still are able to get one real solution. So a significant difference. Let's say we end up in a spot where it's x to the third power equals negative 8. Say, well, no, if that was a square root, we say, no, imaginary solutions, we're not doing that. But here, we just said it a second ago, x can equal negative 2, or x would equal negative 2 in that case, negative 2 times negative 2 times negative 2. And like I said, it all has to do with how many times it's being multiplied. An odd number, there's nothing wrong with getting a negative output. So hopefully that makes sense. Add those 2 notes, pause as needed. Let's finish up. So this is one that we look at maybe even from the start. I know it's a really common spot for students to forget multiple solutions. But before I start solving anything, you could go through and just recognize, hey, at some point, we're going to sixth root here. That's even. I'm going to need 2 solutions for this one. Oh, this one's odd. I'm going to need 1 solution. And then this one, again, because it's even, we're going to end up with 2 solutions. Now, potentially, I guess I don't know for sure 100%. Like we could end up in negative numbers and say no real solutions potentially. But I'm just putting myself on alert a little bit. Like, hey, just watch it here. Potentially 2 solutions versus 1 solution. Okay, here we go. This is your traditional get x by itself, solve for x scenario. So what would we do? If I was showing all my work, I'd divide both sides by 2. X to the 6th power equals, let's see, I'm doing them with you. I don't have them done yet. Divided by 2, 729. There's nothing left to do besides 6th root both sides of the equation. X equals positive, negative. We might have to round. This one actually, 729 is kind of jumping out at me as potentially a perfect 6th, although I'm checking it right now. The 6th root of 729 comes out to exactly 3 when I do it on my calculator, but because it was an even root, I need to account for both solutions, positive, negative 3. All right. Part B, there's nothing to do besides right away, we can undo this cube by cube rooting. Okay. And like I mentioned it, we're going to have to we will have to get some decimal answers. We will talk about putting stuff in simplest radical form involving beyond square roots. That's for a different lesson though. The cubes are going to cancel. I'm left with x plus 4 equals, we already said, hey, 1 solution. Do not set this up as plus minus over here. Right now, I'm getting on my calculator. I'm going cube root, so I got to put the 3, change my index to 3. The cube root of 12, which is, let's see, if I round to the nearest hundredth, we're talking 2.29. And then I got to finish it, right? We're not done. I got to subtract a 4 from both sides to get x equals negative 1.71. Single solution. All right, one more here. Again, we've left ourselves the note. We're thinking 2 solutions. Get the clear anything that's in front of or after the parentheses. In this case, I'm going to get rid of my 1/4 by multiplying both sides of the equation by 4. That's going to leave us x minus 5 to the 4th power equals 40. Now I'm in a position where I can 4th root both sides just watch it on this one. This right now is where the plus minus has got to show up. I can't just tack it on at the very end. As soon as I use an even root to help me solve an equation, that's when my plus minus has got to show up. So over here on the left side, x minus 5, I can do that. 4, I'm going to change my index 4. So the fourth root of 40 is 2.51 if I round it. Again, not done here. I need to add 5 to both sides, plus 5, plus 5. I'm traditionally going to stick the 5 in the front, so 5, and turn that positive negative into plus minus, addition, subtraction, 2.51, and then finish it. Don't leave it like that. Like, we can take this down to just two nice, relatively nice 5 plus 2.51 and 5 minus 2.51. So a couple different looks there. One solution versus two solutions. Again, it's just going to take a little practice, remembering and knowing where and when I should have two solutions versus one. Last one's more just an application, so it's similar. One of two types of problems. So this is not a formula that I would expect anyone to memorize, or it's just kind of an instance where we might see a rational exponent. So as we read it here, the population of a certain animal species after T months can be modeled by P equals C times 1.21 to the T over 3 power, or the T thirds power. Okay, C is the initial population. So this particular example is like a straight up, like, can you evaluate this? Because it's saying, hey, find the population P after 19 months, T months, and when the initial population was 75. So I basically know everything on the left side of the equation here. On the right side of the equation. The initial population was 75. This is like a growth factor. We're growing 1.21, and then I've got my 19 thirds. Are they all going to be like this? Not necessarily. We could end up with, where we know the population, and then we say, maybe we solve for something else. We end up having a fourth root or cube root or something like that. So this one is just more of a, do I know how to do this on my calculator? We practiced a little bit earlier. This is a good look where to go. Here, where it's a number to a rational exponent. Can you do it on the calculator? So how I would do it, I would probably start with this part. I mean, I guess you're going to do it, and we're going to see if we match up, and you're going to know if you can do it. But I would start with that part, 1.21 to the, so again, I'm using this button right there. On my calculator, some of us have like a y to the x button, stuff like that. So I'm taking 1.21 to the, and I'm going to use parentheses and go 19 thirds power. So 19 thirds power. My calculator comes back with 3.343, and then I would just finish with, take that times 75. The reason I'm doing it in that order, I know in the end this is going to be a times deal, and there's a multiplication. Let me write down it so you can get it. Population is about 251, I guess. Probably makes sense to and whoops. If we round it in your whole number there. But I was saying maybe take care of this part first, then multiply by the 75. So that's it. We're out of examples. We're out of slides. We should be able to check off everything on the list. Change forms. That's a big one. Being able to go from one form to another. We did that. Evaluate expressions with and without a calculator. So that was just some of that. We did those, knowing how to rewrite. It still kind of goes back to this skill. And then solving equations, knowing when you have one versus two solutions. So we're checked off. We are good. That's all I got for you. Lesson 5.1 of the books. I will see you in future lessons.